Alright gang, I'm just gonna explain some of these answers. So we already did the first one. It's false. Symmetric has half the data on one side, half the data on the other side. Number 2 is false because the mean is not the best measure when it's skewed. It's actually better to use the median. Number 3, it is true that the smaller value for a standard deviation is less spread. Number 4, true. We know that's the definition of IQR. False, the first quartile is actually in the bottom half, not the top half. You can see the next 3 answers skewed to the right, so it's unbalanced to the right or a little more spread out. Symmetric in the middle, and then skewed to the left, so make sure you get that straight. And then for number 7, the measures of center are just a toss between the median and the mean, and so the mean is going to be pretty good whenever the data is symmetric. So as you look at B, it looks very symmetric there, so we're going to say that's a good thing to go with the mean. If it's not symmetric, it's skewed in any way, then the median is going to be better. And also if you have any outliers, you're gonna choose the median instead of the mean. And then for the spread, very similarly, if it's very symmetric, then the standard deviation is going to be the way to go. Otherwise, we're going to use the IQR if it's a skewed data set. This one we did in class with the whiteboard practice, so you can see the answers there, so I think we're good. Number 9, I didn't really take the time to write this one out. I pretty much did it just as it is, as a stem and leaf plot. So the median, I could see there were 20, I think there were 20 scores there, and then a slash right down the middle, so I figured right in between 54 and 64 is 59, so 59 is the median, and then that breaks up the data into 10 on the bottom, or 10 below and 10 above that. So 10 below, you can see that the halfway point is right between 47 and 50, so that would be 48.5. And then the upper half, you can see it goes 69, then it goes 73, and then in between 73 and 76 is the halfway point, so that's 74.5. The interquartile range, of course, is Q3, the upper quartile minus the lower quartile, so 26. And then we get to standard deviation. And first thing to do, of course, is add them all together and divide by, in this case, 6. So we get 84.67. And then we write the scores right above, and we take each of the scores and we subtract the mean. And that's where we get these deviations from the mean. Some of them can be minus, some can be positive, negative and positive. And then we're supposed to square those numbers, so we square them, and you can see what we get. We should have all positive numbers. And then the next thing to do is to add all those numbers together, and that's the sum of the squared, deviations. So I get 280.9, and then we divide by 1 less than. So then we divide by 5, and so that gives you 56.18, and then take the square root and get 7.50. Now you can tell that the next part C, that Jerry's standard deviation will be higher because the data is more spread out, because he has the 65 and then he has the 100, and that'll just create a bigger, larger standard deviation. Okay. Number 11, we're just looking for that 5-number summary, and oops, looks like I forgot to draw my box and whisker, so I'm not sure I can do that or not on here. Let me see. I think you guys are probably good on the box and whisker, but the lower quartile, would be 34. This is gonna be hideous. So 34, and then upper quartile would be 38. So right there, so that would be like the edge of the box, and then it would go up to the highest and lowest numbers. So up to 62. I don't think anybody really had trouble on the box and whisker on the formative. So down to 24, and then you have a slash down the middle wherever the median is, so that would be like, something like that. So super duper rough. Outliers, we actually have some outliers on this. The outliers are 28 and 44. So let's see, actually, hold on a second. The outliers are 24 and 62, of course. So you have to do the calculation. So you go to your lower quartile and you subtract 1.5 times the interquartile range. You can see the interquartile range is 4. And so that turns out to have a lower bound of 28. The upper bound is 44. And then you can see that we have a couple numbers that are lower than that. So 24 is lower than 28. And then we have a number that's above 44, which is 62. Okay? So that's your calculation. And then, see if I can go down to this next one. The box and whisker plot, it says what's the cost of the upper quartile, so that's right there at $26. And what cost is the lower quartile, so that's $14.50, so you can just estimate those based upon what it looks like. And then we've got the rest of it. So the median. So the median is about $20.50. The percentage of Blu-ray costs between $14.50 and $26. You can see that that's the box itself. So that would be all of this. So that's 50% of the data. And then what percentage is less than $14.50? So that's just 25% of the data, right? It's one of the whiskers. And then what percentage of Blu-rays cost is less than $26? You can see that that is a whisker. That's a whisker, and it's all of this, so that is 75%, because you only have a whisker that's above that. So that's where we're getting that. And scrolling to the next part. It's my first time doing it this way, making a video this way. So is that it? So yeah, that's it. So hopefully that makes some sense. And let me stop this.